Okay, so I'm reworking the two problems from the practice, okay? And I'm going to do it kind of a shortcut method, okay? I kind of call it the box method of um, graphing trig functions, and you'll see why in just a minute. This is k, start that over, f of x equals k plus a tangent x minus 2 pi. So we're doing the h. So we're doing the exact same thing, okay? So my center line's at -1. My amplitude is 3, periods 2 pi, and we've gone to the right 2 pi. Okay? So what I'm going to do here is I'm not even going to graph the parent function. I'm going to start by actually graphing my information. So for instance, my center line. My center line is at -1 right here. Okay? Then I'm going to talk about my amplitude. My amplitude's 3. So amplitude starts from the center line, 1, 2, 3. 1, 2, 3. So my amplitude's 3 away. So this represents my amplitude of 3. Okay? And then my last part is going to be my period and my shift. So my period's 2 pi. So it normally would start at 0, but it's been moved over 2 pi. So it starts here at 2 pi. And my period is 2 pi long, so 2 pi to 4 pi. Okay? So basically, what I've created for my center line, my amplitude, my period, and my shift, I've created this box right here. This box represents where my trig function is going to be. Okay? Then, since I'm graphing tangent, what I do is I graph the key points for sine. So sine has its zeros on the center line, so at the beginning, end, and right in the middle. Then a maximum, and then a minimum. Okay? So, when I go to graph my tangent function, tangent has the same zeros as sine. So tangent has a 0 there, and a 0 there, and a 0 there. Where sine has its maximums and minimums, tangent has its asymptotes. So there's my asymptotes. Okay? And then I know that tangent goes like this. And since it's been vertically stretched, that one coordinate that's usually here has been stretched up to 3. So here, this one's at down here, and this one's up here, and this one is down there. So basically, using this box method, I'm able to graph this entire function like this without having to actually do each and every transformation. I use the information to create this box, and then I graph it. And if you look at that compared to our answer, which is right here, you can see here is this box right here. And we are, right there where we need to be. Okay? So this method's a little faster. Same thing with the cotangent function. Okay, and I'm going to do this one just really quickly. My center line's at 3, amplitude is 1/2, my period was pi. Okay, so again, start off by my center line. Center line's right here at 3. Amplitude is 1/2, so right here. So half away from my center line. My period is pi, no shift, so it starts here, ends here. Now, for this one, I'm going to plot those major points of cosine. So cosine starts, ends at a maximum, and the middle has a minimum, then 0 here, and a 0 there. And just like cosine or sine and tangent, where cosine has its maximums and minimums, that's where cotangent has its asymptotes. So there's an asymptote there, an asymptote there, asymptote there. Shares the same zeros. and then right here, right here, right here, and right here, using the box. And that's what my cotangent looks like, using the box method.